Plastics are used in an enormous range of products. And that's surprising, because they're barely 100 years old, and it's only in the last 50 years that their full versatility has been appreciated and exploited. Today, there are few domestic or industrial objects that don't contain plastics. Few that haven't had their design, their performance, even their durability improved by plastic materials. The Mini Metro, possibly the most important British car of the decade, uses plastics to great and admirable purpose. Bumpers and front grills are formed from plastic material because it doesn't corrode easily and absorbs minor impacts more efficiently than metal. Electrical control boxes and wires use plastics because of their excellent insulation properties. Oil filter housing, the cooling fan, containers for coolant and brake fluid, they're all made from plastics, which are light and can be formed into intricate shapes with relative ease. The interior is finished with various plastic materials. Plastic is hard-wearing, stain-resistant, and it doesn't scratch easily. Some plastics flex and collapse under impact, and that makes them particularly valuable in increasing the safety of passengers. But above all, the relative lightness of plastic has done a great deal to reduce petrol consumption for motorists. The lighter the body, the more the mileage. Plastics belong to a group of chemicals called polymers. Polymers include fibers, paints, adhesives, and rubber. The name polymer describes their molecular structure. The building block in the manufacture of polymers is a simple molecule called a monomer. In the creation of a plastic material, thousands of monomer molecules are encouraged to join together to form larger molecules. To persuade the molecules to be sociable, an initiator or catalyst is usually introduced to help the chemical reaction. Then the molecules combine to form long strings or chains composed of thousands of monomer units. These chains are formed in a quite random way, some short, some long, all twisted and tangled like spaghetti. The joining together of monomers to produce these long chains is called polymerization. Here we can see the process at work. In the beaker, two different liquids containing two monomers. Where the liquids meet, the monomers react. The polymer is formed, and it can be drawn off. The plastic material being formed here is the best-known plastic of all, nylon. It made its debut in wartime. Nylons for glamour, parachutes for pilots. The hundreds of thousands of tangled chains that compose the nylon lend the material astonishing strength. The raw materials for making plastic usually come from oil, although they can be made from other organic materials such as coal, wood, or vegetable sources. This refinery is producing vinyl chloride. At room temperature, it's a heavy gas. Under pressure, it becomes a liquid, and it's usually used in this form. Vinyl chloride is the building block for polyvinyl chloride, PVC, and it's made from ethylene and chlorine. The vinyl chloride liquid is pumped to the polymerizing plant in the refinery. Here it enters a pressure vessel called an autoclave. In the autoclave, the vinyl chloride is mixed with water and a catalyst, which sparks off the reaction. In this batch process, 95% of vinyl chloride is converted to PVC. The remaining vinyl chloride gas is trapped in the solid particles of PVC. The PVC itself is in the form of a suspension in the water. To dry it out, the slurry is sprayed into this 50-foot high cone and mixed with hot air. A fine powder is precipitated, and this is put in bags. There are two kinds of synthetic polymers: thermosetting plastics and thermoplastics. The main advantage with thermoplastics is that they can be reshaped many times over.